Hi everyone, welcome to Bamboo U. Welcome to this incredible workshop space in this dome. Thanks for joining. We say hello from Bali. Let us know where you are tuning in. And here we are with Kristof and Garvin. We are very happy to have you guys here after more or less 1 year and a half after we all built together this beautiful dome.
Yes.
Thanks so much for having us. Yeah, it's really exciting to be back. We were here at the end of August last year for one of the design and build workshops here, where we had a big group of students to help us build the main structure. And I personally hadn't been back to see it in person since. And I was here for the first time a couple of days ago. And it's absolutely mind-blowing. It's a beautiful addition to the campus. And the photos and videos won't do it justice. So you have to come and check it out.
Yes, I think the mind-blowing thing about it as well, this was actually built by students. So this was built in just 11 days. And it's something incredible that I would never imagine you could actually make with people just coming here, experiencing bamboo for the first time as well.
So before we jump into our nice talk about how we built this project, how you were conceiving this idea, etc., please let us know a little bit about you guys, like your background, where you're based now, where you're from, how you get into architecture or bamboo, and a little bit of you.
Yeah, so hi, my name is Garvin Goepel. I'm a researcher and designer who specializes in the implementation of augmented reality technology in architectural design and construction processes. I'm running my firm called Augmented Architecture, and I'm also teaching at Hong Kong University. I'm also specializing to teach this technology. I started with bamboo by working together with Kristof a few years ago. So Kristof is an expert in bamboo that we can share in a little bit. And he brought me into this bamboo world, having an interest in also implementing augmented reality. So since then, since 2019, I think our first project was, we're trying to combine these specialities to bring augmented reality and bamboo together.
Hi, everybody. So I'm Kristof Crolla. I'm a Belgian architect. I've been living in Hong Kong for 15 years now, where I'm a professor at the University of Hong Kong, running the Building Complexity Lab, which is an academic research lab. I also have an architecture practice there called the Laboratory for Explorative Architecture and Design. I've been working with bamboo for 13 years now, something like that. And one of the biggest projects that we did that kind of made a big ripple was the ZCB Bamboo Pavilion, which was a very large bending active bamboo shell structure that was made in Hong Kong without any joinery per se, but like the Hong Kong bamboo craftsmanship that they have there that they use for the scaffolding building there. And since then, I mean, I've always been a fan of the amazing bamboo works that are happening here in Bali, from the Hardy family, the Green School, what Ibuku is doing, Bamboo U is doing, Bamboo Pure is doing. And so in the wake of the ZCB Bamboo Pavilion, we started to get in touch. And so I've been giving talks for the Bamboo U course for maybe 5 years now, or maybe a bit longer even. And then once the pandemic was over, we were super excited to finally be able to come here and do some of these in-person design and build workshops. But for the longest time, what I've really been dreaming about from an academic design research perspective is to build a giant pop-up grid shell, which is what we have here. And yeah, that opportunity came in August 2023 now, so a year and a half ago. That was really fun. Yeah, it was a really important moment to come back here for that.
So it's very interesting also that all the bamboo industry and all the constructions that you can see made out of bamboo here in Bali, like a big part of that starts here in Bamboo U as an experimentation, as an exercise of big buildings, of small buildings, to try to test, to think about like, what if we pop out like just one dome, like made entirely with participants during 11 days. So tell us a little bit about the process, about like how you get to think about one project, what's the ideas behind, what's like the work also to make it happen in just 11 days.
Maybe I'll talk about that, because academia, we have a role to push the boundaries and do things that you cannot easily do in practice. But the challenge is to do that at scale that starts to approximate what is happening in practice. And that's why Bamboo U and the campus that we have here is so great, because it becomes a giant playground in which we can actually do experiments at building scale. It's very rare to have access to that. And for this project specifically, we were very interested in trying to see how we can make the design of very engaging, a different type of architecture, more easy, more efficient, more cost effective, more labor effective. And half a century ago, in the 70s, Fraiotto had built this amazing project called the Mannheim Multihalle, where they basically made a flat grid made from wood on the ground, and then they lifted that up to make this giant hall that's like a doubly curved bubble shape. It's an absolutely spectacular building, and we have been thinking for a while at the university in the design studios there, like, can we actually do that with bamboo at a scale? Because bamboo is a very different material, comes with a different level of craftsmanship, different level of tolerance. So we've been very excited to see if that would actually be possible, and then to come here where all these amazing craftsmen from the Balinese context where you live and work, and they know so much about the material, about the details. Can we work with them to try something entirely different that even they have never done or dreamed of? And that's kind of the academic experiment here. So it's standing on the shoulders of giants, like it's in a lineage of a series of these material experiments, but just for the first time brought into the world of bamboo, which is kind of a relatively new material in the international architecture scene. It's made a huge boom in the past 10, 15 years. So it's a very interesting environment to start pushing these boundaries. And,
Maybe also something to add to this is also the computational workflow
Yeah.
that's behind that. And I think that's also something, because normally you have a design in mind, it's very static,
Yeah.
and you're planning to build it, then you're planning your construction materials and everything that you need to do. But if you remember the first week that we have been here, there was a certain amount of material being available, and to actually plan in accordance to the circumstances, to plan to the materials and everything, you could actually in real time tweak the design. So the design that was developed wasn't actually a design that was fixed, right? But with the flexibility, you could actually, in that week, actually adapt to what was available. The material testing that we did on site with the grids, with the sizes of the grid and everything, and with that really, react to actually the circumstances that were here.
Yeah.
Let me elaborate a bit on that, because it's an interesting point. The way historically bamboo buildings are built is through scale models, where materials are used that are made from bamboo because they behave in a similar way. But that kind of restricts to a certain degree what you can do with it. With digital tools nowadays, we can assign geometries behaviors that are similar to the way bamboo would behave in reality, or the way model making materials behave. And so if you bring that digital component and that parametric control over digital models in this world, you can basically virtually recreate what a scale model would do. But a scale model, as Garvin was saying, is static. You make one, and you can change it, but it's not parametrically controlled. And so what we did for this dome here, we made a scale model digitally, which is like a physical model that you would make, but then in the computer, where all the curves had a behavior similar to how bamboo would behave if you would make a scale model, but they're linked to a parametric interface, which means that if you change some of the sliders, the design optimizes in real time without needing you to redraw all the drawings, for example, that come with it. So one of the really fun parts, and that's where Garvin comes in with augmented reality elements as well, was we came to site, put the holograms up, and then we could change the design as we saw it in real time, because it's a parametric model.
Maybe just
So it might sound like a little bit futuristic for those that are watching our YouTube. Please let us know where you're tuning in, and if you have any question about how we built this building, how we were thinking about the process, etc. Inara and the marketing team is behind our camera, so they will be answering and replying all your questions that you might have. So please feel free to ask any question that you have there. So just to elaborate a little bit on how we did the construction, because remember that is participants coming in here, spend 11 days in our workshop, and then get to build this kind of things. So of course we had some preps before, like foundation points, like some studies before, testings, etc. But what you have been listening about augmented reality, about 3D models, is that this building was first modeled in a virtual reality, export that into HoloLenses, so you were able to see this project through the HoloLenses.
Let me elaborate a little bit on that one. So I'm sure you all are aware of virtual reality. So there's like the Oculus, for example, and you're completely detached from reality. So it's used in games a lot when you're in a completely virtual world, like almost a game like virtual world, right? But it's completely unrelated to reality. So augmented reality, on the other hand, is superimposing digital information on top of reality. So it adds additional information. So you can see everything that we are seeing right now, but you can see, for example, something on the table, like a tree, an animal, or even an architectural design. But now if you're bringing this design in scale 1:1, and if you're seeing this as a hologram, we can talk about a mixed reality. And in a mixed reality, you're actually mixing this digital component together with real world occurrences. And this is where the magic is actually happening, because what happens is that the construction becomes an assembly almost of a three-dimensional puzzle, where every piece that you see in front of you in a hologram has to be matched with this physical component. And this makes the construction so easy. So I think traditionally you're working a lot with physical models that you have on site, and then you have to visualize the physical model in your mind and actually the scale 1:1 and translate this model into something bigger. But now this technology allows you to project this design in scale 1:1 as an overlay over your field of vision. So you actually see in front of you what you need to build. So the communication flow of the design intent into its physical manifestation, it's streamlined in a much more easy way.
The cool thing, the very first day we were on site, we brought these HoloLenses, which are like ski goggles almost that you wear, and you see the world through it, and you see these holograms. We brought them on site, and we're walking around here, and you see the building as if it's there.
Yes.
And then you can start to see, because we designed this from Hong Kong. We knew roughly what the site was. We didn't know where the palm trees were, where the axis was, or where the sun was coming up. And so then you're here, you see this building in front of you, and then Oren, who's the boss of Vambu, came in like, oh, maybe we should have an opening there so that the entrance is better. We can lift the skirt of the shell a bit, and in real time the whole model updates and kind of responds to that. So imagine that you're working on an architecture project for a client, and rather than you trying to explain your drawings on the table in front of them, you actually take them into the building, and they can have feedback, and they can discuss with you what it is that they want, and instantly in real time you get an update.
Yeah. And that brings me to my next question, which is like how to communicate what we're about to build as an architect. Because I mean, through the story of architecture, we have been drawing, we have been doing sketches. Some of them they are very accurate, some of them they are just rough ideas. Then we come to 2D drawings, 2D plans, 3D models, rendering images. So there's always a need to communicate the idea of what we're going to do to the client, what we're going to do to our colleagues, or to the builders. So what was that process, or how you see the carpenters when they put the HoloLenses so they can understand what's inside the mind and what's inside the architect's mind?
Yeah, I think they were completely mind blown for the first time trying on these goggles, because I think for the first time the communication barrier that you normally have by showing them a bunch of drawings, which are 2D drawings flat on paper.
Or not just that, we don't speak Bahasa,
Exactly,
so the language barrier,
and communication
but then to basically show them in scale 1:1 in front of them what needs to be built is actually this mind-blowing factor. I think also probably for the students it was increasingly valuable, because not everyone coming here is in training in architecture, not everyone knows how to read drawings, right? So what we are trying to push in academia in our research is to really get this threshold of the drawings away, to not just communicate with two-dimensional drawings that are extremely difficult to understand if you're not trained in reading them, but to see if we can use these latest technologies to make this communication barrier much easier. I think AR is a really fun way to do that.
And what was fun about the workshop is that this is a very simple and logical building. It may be complex in its geometry and it may look quite impressive in its scale, but it's actually a very simple series of steps that it takes to build. And by using these holograms to assist with holographically at each step what needs to be done, it becomes very efficient and direct to engage people into the whole construction process. Whereas otherwise, maybe somebody would have a specialized task or would need to be briefed and rebriefed and things needed to be calibrated. Because it's so accessible, it's really fun for students because they come and spend a bit of time on this part of the building and on that part of the building, and the choreography of kind of orchestrating this collective dance that it results in this product becomes much more fluid and streamlined and therefore fun and engaging. It was really nice to see that with the students, everybody kind of being able to take part in this process.
I love that analogy of the dancing and all that choreography. So walk us through the process during those days of construction, because we have the foundation, and we have just a pile of bamboo poles over there. And what was the process like? What the participants get to do? What we did the first day, second. How was the process? Tell us a little bit.
I think at the beginning it was quite frustrating maybe for a few participants because we were spending a lot of days to lay out the flat grids on the floor, right? But then to have actually this hologram in mind, because everyone was trying out the holograms to actually see how it will look up once this flat grid is being popped into shape. But then to actually see this actually happening in reality with the crane, actually lifting up the grid. I think that was probably the most exciting moment of the
Let me
workshop.
clarify that by maybe talking very much step by step through all the process. So we had this big pile of bamboo. The first thing that people had to do is basically interconnect them all in long members of, I don't know, 40 meters long strips. And then with those, we made a grid on the ground here. And then once that grid was in place, a massive crane came in. We made like a support frame underneath it, and that crane came down. We hooked it up to the grid, and then we slowly lifted it up. And that grid slowly came up and started to become this dome shape. And while that was happening, we were trying to catch it at the bottom with scaffolding, and everybody was kind of helping coordinate how to get it to this final shape. Until the crane was at its absolute maximum that it could hold. All the alarm bells were going off because we were really pushing the limits of what this crane could hold. And then that was there, and then we added support scaffolding around it, basically locked it in place. And then that was almost the end of the workshop. Everybody left, and then the craftsmen on site here after the workshop then finished it off. They added extra diagonals, finished off the roof, connected the whole support structure underneath it in a relatively short amount of time. Because it's such a simple and logic process, actually, they were able to finish the whole building into its final form. But it was very exciting for the students to be part of this magical moment, because to my knowledge, it's the first ever bending active pop-up grid shell that has ever been built at this scale. And just to be there at the moment when it's kind of being pulled up, and to see it and also in some of the videos, it's just it was absolutely wild. Plus, we had an earthquake even in the middle of it. One of the nights when it was hanging there, everybody was sleeping here. There was an earthquake here in Bali. So everybody was like, oh, what's happening? And luckily everything was still in shape. So yeah, we survived the earthquake in the process.
Yeah, it was very nice. Like I remember like the three of us being on top of the scaffolding, like just in the most dangerous spot below the crane, like just hearing how all the structure was cracking, but at the same time it was beautiful how the squares became a diamond shape.
It was like more the popping noises that bamboo makes when it bends. It was nothing was cracking or breaking. It's like the natural sound that bamboo would make if you bend it. Like it creaks a little bit.
It's like if you are tightening a rope.
Yes,
is that kind of sound? Expected sound.
Yes,
and we were like just enjoying that moment.
Yes.
And so tell us a little bit about what were like the challenges of being able to see that happening, and also how accurate or not accurate was with the 3D model on the software.
I think in terms of accuracy, that is something that is very easy to control with the HoloLens. So you can precisely see where you need to push it a little bit higher, where you need to tweak it, how you need to rotate it, also with the crane, when the crane needs to stop with the correct height. So I think with all of this, the technology was actually extremely helpful. I think also just being underneath that was extremely spectacular at that moment, and to combine actually this massive grid shell together with these holograms was absolutely fantastic. I think it's also one of the largest ever built structures using augmented reality, actually. So I think there are not many precedents to have holograms on that scale and actually manage and control a shape like this.
And that comes with risk and some boldness, and it's really nice to kind of have the bamboo cowboys here willing to take on that risk, because there are digital tools available that allow you to simulate how something will deform, but they're approximative. They're not a direct match with exactly what's happening in reality. So there's a huge unknown there. And we can simulate to our best attempts how the whole thing will behave, but until you press play in reality, you will never really know it. So we did ahead of time try to simulate every single parameter of what this pulling up was going to be doing, but then to do it on site, it's an entirely different game, because I mean, bamboo is a natural material. Every column is different, so it will behave a little bit differently throughout the shell. All the connections are done by hand. So if somebody ties something a bit more, it will become stiffer. So there's so many variables and so many uncertainties in the whole project, that the beauty of the project to me lay in trying to control just the parts that you need to control and letting go in the parts where you cannot control it anyway. And that's very much true for any bamboo architectural project. The craftsmanship and the materiality dictates what the design will in the end look like to a certain degree. They're a component of it. But once you start making these big grid shells and you're deforming them, and the level of tolerance that you need to have to this tolerance of the material, it has to be quite high. And that was actually really fun to see. And it did require all hands on deck as this grid was going up to assess where is it doing well, where does it need a little bit of a hand, where does it need a push. And that was really fun to engage all the students in that whole process. Because you cannot do it with just a few people. It needs kind of this collective spirit, fully aware and fully understanding of what needs to be done to push everything in place.
One participant like just holding like two intersections and then lifting that so the crane can go up a little bit more. It was very fun.
And it really allows you to understand the materiality, that it gives you this hands-on experience where you get the sense of the weight of the bamboo, you feel the tensions in there. And that's something that you're not going to get from a textbook or from an online course, tutorial, whatever. Like you kind of need to be there to feel.
Yeah, I think that moment was actually special when we lifted the grid, when the foundations were in the way, when we're actually 50 people here on site with the grid, everybody in the corners. I think you were on the container, so navigating, we need to lift it up here, then talking with the crane pilot, right? So I think that was actually really, like the collective effort, and you need 50 people for that. Like you can't do it alone.
Pilot just very comfortable, like smoking, like lifting the crane. It was very fun. And I would like to for you to explain or to talk a little bit about like all the softwares and what kind of plugins you were using and what kind of parameters or information you were using for that for the 3D model. For those of you interested on computational design, because everything was basically from the 3D model to reality.
There's two parts of it. There's the procedural design or digital modeling, and there's augmented reality part. So maybe I'll talk about the procedural parts first. So there's a lot of CAD softwares, computer-aided design softwares like AutoCAD or whatever. There's one peculiar modeler that we really like to work with, is called Rhino, which is a 3D modeler that allows you to draw basically anything. But in that software, there's a plugin called Grasshopper, which is a computer programming software. But it's not just, you're not typing computer code, you're working with buttons that have little scripts running inside of them, so you can basically draw your computer code. And so that's a way that we can create this parametric model. And there's another plugin on top of that called Kangaroo, which allows you to produce these physics simulations. That's where you can assign a behavior to a curve to, for example, always try to straighten itself out, or to pull at something and then the geometry will follow. And so with these tools, and we have a lot of tutorials for free available on our lab website. So if you go to bsl.hk.hk, the Building Simplexity Lab website, we have almost 200 tutorials freely available on Rhino and Grasshopper and all of that, where you can get all the basics on how to do that. And that just produces you the geometry. And then with that, you go to the augmented reality, which is an entirely different environment.
Yeah, so for that, it's very easy nowadays to link this model with the HoloLens or with the phone. So there's an amazing software called Hologram, developed from a program team in Australia, which creates this live link together with the Rhino model. So everything that you see in Rhino in a 3D model can then project it on top of the HoloLens. You can project it on your phone, then you can see that as well. But maybe just to add something to the parametric modeling as well, I think the beauty for that was really in the first week that it allows for this flexibility to create it. So with some panels that you can create, you can immediately see how long your bamboo is. You can see the weights of it. You can see all the information that you need by just changing one parameter. So I think that really allowed us in the first week to actually fine tune this design to what it actually is.
And I remember that a very interesting thing that was happening during the construction is that all the questions that were arising in the moment of the construction, there was a way to get the solution and the answer through the 3D model. For example, like where is the best place to place the grid shell, like between which foundations to be able to optimize the grid shell or to optimize the structure. Like many questions that were asked by the participants, by us, by Orin, by yourself, and they can be answered by the 3D model. So that was very interesting. There's always a way to ask for that information.
And that's the important task of anybody who's designing in a bamboo context is that you need to have an appreciation for the realities of the materials, of the craftsmanship, and what's happening on site. And if the design is made with those parameters in mind, then there's this beautiful synchronicity between both.
Yeah.
Like, for example, many people don't know this, but bamboo can be absolutely a permanent construction material. If it's treated well, if it's protected from the rain, if it's protected from direct sunlight, it can last forever. There's bamboo buildings that are more than 100 years old. So here, this design is totally following these principles, and that's something that you can simulate. Like you can do a sunlight analysis to see, are all the foundations deep enough so that they're not overexposed to direct sunlight, and then you can do a rain analysis, even with a wind analysis. All these fun things that you could theoretically do with a model and a flashlight and maybe a water tap as well. But digitally, it's much more. Well, it's quicker. It's maybe more versatile. But similarly,
it allows you to adapt to it in real time as well.
Yes. And now with AR, you can take that from your screen and put it at full scale on site and really bring people into that world, and that's really fun.
And in terms of the augmented reality, I mean, we were using HoloLenses, but you were mentioning that you can actually just take your phone or take just an iPad and actually look at the 3D model in, just in the table, to that. So it's not a like a very expensive technology. Like with the phone that you are carrying in your pocket, you can do that.
Exactly. So Kristof was already mentioning the BSL website. So on that website, we actually have tutorials to teach students actually how to use it, how to link your Rhino model together with your phone. So again, with the Hologram app, it's very easy to do this. You scan a QR code, you download the app, and then you actually have a representation in augmented reality of whatever you're modeling in Rhino. And I think also the beauty to that is that the accessibility to a smartphone is given, as you were saying. Like not everyone has these fancy goggles, HoloLenses, they're quite expensive to get, but everyone in the world has a smartphone available. So what we are also doing in the lab is we're actually developing apps, augmented reality applications that are standalone applications that you can download from the App Store. And then with these apps, you can actually democratize the accessibility to building information, and everyone with these applications theoretically could actually construct their own living space, other designs and so on. So that's another research area that we're tackling.
So imagine you're coming here to site, there's all the Balinese craftsmen there. There's a language barrier. You try to show what it is that you want them to do. You just pull out your phone, click on the ground, and they see it. And then you leave, and then they pick out their phone, and they can continue with it. And again, if this choreography is pre-programmed in this building information communication flow, then you can tap into all these fun technologies that are nowadays available in your pocket and suddenly do something that you weren't able to do before. And that's why it matters to experiment with this in a kind of academic context like Bamboo U. This is where you can really push the boundaries at a scale. And in practice, theoretically, it's also possible, but there might be some hesitance toward it. So to have a proof of concept built at the scale of a full-blown big building is really important, because it really changes people's minds. And because this technology is available, if the students come here and they participate in it and they get excited about it and they see the value of it, they can take it away with them to wherever they're coming from and maybe start to build up on that. So it may open up opportunities for anybody outside as well.
So now, expectation versus reality. So before we start the course, before we start building, before you came to Bali to start building this beautiful dome, what was the expectation? And now that we're actually here below this beautiful dome, and we have been using this dome for workshops, carpentry days, model making, talks, even Kechak dance, this Balinese traditional dancing, like this place is alive now. So what's your thoughts on that, like expectation and reality now?
I think we are extremely happy with it, obviously. I think also something maybe to mention, it's actually the second time that we were here with the dome. So there has been a prototype built on the campus with the dormitories as well. So we built 2 pop-up grids with also using augmented reality.
Much smaller
scale. So I think having realized that with the group here with Bamboo U students beforehand gave us a lot of confidence to now scale things up as well. And I think the outcome is spectacular. Like super happy with it, but I think that's also a big part of your team and the expertise of the craftsmen actually doing these beautiful details with it as well.
I think it was really an experiment, and we didn't know if it was going to work. And if you look at it right now, still the amount of structure that's in the shell is very, very little. And we've used all engineering common sense that we could do, but there's no proper structural engineering method available to even fully simulate or test this. So there's a huge gamble, or maybe not a huge gamble, but a gamble that we cannot really identify ahead of time that we're taking when we start this course.
Mhm.
But it's always super exciting to see that this experiment then works.
Mhm.
Like in an academic context, an experiment that fails is still useful because at least you know it didn't work.
Yeah,
But then, of course, if it works, it's much, much more exciting. So to see that, first of all, that it was actually deforming in the way that we predicted, and then to stand underneath it with all the scaffolding inside of it was already one thing. But then a few days ago, when I arrived here for the first time since the last workshop, to see it at full scale, like the hair on my arms and neck stands up. It was like it's unbelievable. It's really fun. But the most exciting thing also is that now that this is demonstrated to be possible, the question now is what's next?
Exactly. What's next? Like, what's the future? Like, once we try this one as a bigger example of the mini domes that we have here, we have two, that people that come to the in-person course can stay there. So people are using those spaces. So what's the future? Like, maybe like moving faster in terms of augmented reality, maybe utilizing more 3D softwares, maybe the process, the construction process, like what's the future after doing this exercise, this big experiment? What's the future? How does it look like?
Well, there's a few areas. Specifically for this dome, I would say, if this is possible with thin sticks, short length, and you could span something like this, there's nothing that would hinder us from actually doing a bigger one.
Yeah.
And we're imagining, what if this becomes like a convention center? Or if you change the geometry a little bit, maybe it becomes a train station or something like suddenly a typology becomes available that currently was maybe the bamboo didn't really have access to. And so I think scaling up is something really interesting. Like the design solution spaces have been opened up, and it would be really exciting to continue this experiment straight in that direction. So that's just scaling up. But then what's also really exciting to imagine now is, as a designer who has access to these tools, because the tools that are available for everybody, like what else can you do? Like, how can you open up the design solution space of bamboo architecture in general? Because the whole communication flow of design ideas to carpentry to craftsmen changes, and how can you collectively do something more sustainable, different, engaging, more fun?
Yeah, I think also especially now with AI, right? Like when you're testing AI tools and when you're actually seeing the vast amount of possibilities that are produced nowadays, like with these spectacular forms that are not working yet, right? To see just how can we actually create these forms and how can we push the boundaries? How can we find smart systems actually to implement that? But also how can we engage a larger community actually to engage in bamboo architecture? Because I think that's also an issue in Bali. Like bamboo is actually getting less and less used. I think concrete is becoming more popular, stone's becoming more popular for the locals. So I think to reimagine what you can actually do with bamboo to gain this trust again in this local building material, I think that's important. I think that's why Green School Bamboo use actually demonstrated for what is possible to actually showcase the possibilities of this amazing material. And I think also we want to thank you for the trust that you put in us to actually experiment with these ideas here. Like as Kristof was mentioning, this is like a demonstrator. It's the first of its kind, but now having demonstrated that this is possible, this can be implemented at various scales, at various sites across the world as well.
Yeah, no, it's been an incredible experience, and we've been talking about like it was a mixture of excitement and fear at the same time to see like it's gonna work. We don't know. Let's try it, but let's trust. And it was like a very intuitive process. Like everything, even the foundation details was like just intuitive. Like okay, how many poles will land on a bamboo foundation, bamboo pillar, more or less 80 centimeters, 1 meter down. Okay, let's do that. Boom. No calculation, everything like intuitive. So also in bamboo, you were very glad to have people like you that can bring these ideas, that we can test it, that we can try to set a precedent of what's gonna happen next on bamboo construction. So we're very happy, we're very glad that you're here, back here and using this space.
Thank you. And I think also for the student, it's just amazing to witness this process as well, to be part of this experimentation, to be part of these, like, of trying these new things.
Because to take risks with experiments, like we don't take crazy risks, right? We're not doing anything dangerous here. We kind of we're going outside of our comfort zone. But because there's so many different experts here with different levels of expertise, we can kind of collectively go out of our comfort zone by trusting each other on what it is that we can bring to the table. And that's why it's so unique to have that here, because the craftsmen bring their understanding of how to connect everything and bring the material in. We maybe bring in some computational tools. Just being here, there's a live catalog of details and tests that we can sample from. And if you don't have access to that, the discomfort of trying something like this would be unsustainable almost. But that's why being here, it's kind of the beauty of it, it's kind of the safe space to really push the boundaries and go outside of it. And that's why we love coming here. That's why we really like to be here. Plus some of the other teachers that you bring in. That's why everybody wants to come back.
Well, Kristof, Garvin, thank you very much for being here. It's always a pleasure. It's always fun to be working, to enjoying the nights also. And it's always fun to have you here. And looking forward for more adventures.
Yes.
Thank you so much for this.
Thanks for having us.
Thank you. Bye.
Bye.